Joshua Frank. Quick introduction. I'm a co-founder at Tesseract Mobile. We were a mobile game development company for most of our history. Back about, I don't know, 5 years ago, or something like that, we sold off most of our game assets to a media company. And then about 3 years ago, we kind of pivoted to AI. That was the time that Stable Diffusion came out. It was very complicated to use, and the idea was simple. We'll just make a simple art generator where people can get on the mobile phone and generate images. At the time, I think we were the second app on the Play Store to actually be able to do that. So I've been working with AI full-time for about, I guess, 3 years now, and then as a hobbyist, going back, I don't even know how long, 7 or 8 years. So I'm going to be talking about Model Context Protocol, or MCP, today. So feel free to interrupt me at any time. I like questions. I wasn't sure exactly what angle everybody was going to be coming at for this talk. If you have something specific you want, use case you want to get to, please just interrupt me and I'll cover that. So I'm going to go over the basics. I'm going to explain what it is, why you want to use it, some of the use cases, and at the end I'm going to show off what I think is kind of an interesting demo. So just to cover what it is, so Model Context Protocol is it's a wrapper for APIs. It's a way for your large language models, your LLM, you'll be using that term. I hope most of you, I'm kind of assume that you're all kind of used AI since you're in this group. You understand what an LLM is. When I talk about that, I'm talking about ChatGPT or Claude or those kind of products. Right now, most of AI is you ask it a question and it gives you the answer from its current static world knowledge. Most of what I'm going to talk about MCP is how to get context into your requests. So context is pulling in information from your customer database, looking up information on the internet, that sort of thing, and how to make your AI more useful. Okay, so it's a little bit of a reiteration of that. So MCP sits as a kind of interface in between the language model and your back-end systems. It's your databases, your productivity apps, your calendar, your email, all that kind of thing. It's a way of simplifying the connection between the language model and the back-end services.
So, like, how similar is this to like Figma or like a lot of API standards in finance?
For
what are some similar things from the non-AI?
From the non-AI world?
Yeah. So like a similar FHIR and like electronic health records, for example.
I'm not familiar with FHIR, but it's similar to REST API. Right. So you would have an app, it makes a request to a server, the server then either changes something on the user's behalf or sends information back to the language or to your app.
Right.
I think I might get into why this wrapper is important. We'll cover that actually in a slide or two. Cool. Of why you're going to want that.
Is that, I don't mean to interrupt again, but
yeah.
Is that similar to like Docker, where it's kind of a wrapper or containerized?
No, Docker's more of a way to like contain all your files and your dependencies for something. This is more like a translation. Think of API as like speaking French, and MCP understands English, and your LLM understands English, and MCP takes what the LLM understands and talks to those other services, translating it back and forth between the two. Even though you're like, and we will get to like, LLMs could talk directly to it, but it may not be the best option. Okay. Okay, well, that may not work, but I was gonna do is YouTube blocked?
Are you on our?
Hilarious.
Yes.
The guest. Okay, well, we won't see the little videos. It's just a short little cute clip of. So I like to go back to explain something that I don't think is commonly understood about language models. Language models, you take your question that you send to them and whatever information you're sending to them, they process that information and they create an answer and they send it back. After that, they're gone. They stop existing. They have no record of what happened before. They don't have any information in the outside world. Each request is a fresh and new request to the language model. So then you might be thinking, well, you know, I talked to ChatGPT. It knows what I'm talking about. It remembers me. That's because when we talk to these language models, when we chat with them, in the background, the applications that are doing the chatting, they fill in all that information. So everything you sent to it previously, all your previous chats, gets sent back to it in one giant block of text. And that's the context window of the language model. So all the language model knows is it knows its predetermined world knowledge, which is quite a bit. You know, if you ask it the capital of Paris, it'll tell you capital of France, they'll tell you Paris. But anything beyond that has to be fed back into context to the language model. So I just want to be real clear on that because that's important for the rest of it. And I think a lot of people miss that point.
ChatGPT web app is like kind of a crappy AI agent, actually, right? It's not really ChatGPT. It's got a lot of its own limits.
Yeah, like ChatGPT, for example, all the previous history that you type into it, that gets sent back every time you ask a new question. Your entire history for that session gets passed back in. Plus, they have added, like recently, and by recent I mean within the last few months, memory, so it now remembers previous conversations, things you like or don't like. You know, it tries to, it knows I'm a software developer, so it tries to gear its answers in the form of code. Like sometimes it gives me too much. Like sometimes I don't want code. I'm like, stop it with the code. But since 99% of the time I do want it, it's always giving that to me. But I don't have to ask it each time. But that's not the language model. That is the ChatGPT web app that is doing that and feeding that into a language model. The video is going to be a Rick and Morty Meeseeks, and if you guys have ever seen, if anybody's seen that, they come to life, they do a task for you, and then they disappear. And that's kind of the way LLMs work. Okay, so from the technical side, we have the protocol. I'm not going to dive too deep into the technicals of MCP. I really want to just kind of cover what you can do with it. But from the technical side, it basically takes the request of the LLM, it wraps it into a JSON, and it then passes it back to your tools on the back end. So you have three major things. You have your tools. That is your connectors to email, calendar. Keep using that. There's like so many examples. There's resources. This is like customer database. You have a customer do a chat with the LLM, and it wants to call back and look up like what's their order history if they're having a problem with an order or something. So that's another feature. And then prompts, which is not used a lot, but it is kind of an interesting use case where the language model can send some context to the MCP server, and it can actually send a formatted prompt. So the example they always give on their website is like, help me do this code review, and it fills out all the fields of what the pull request is, what the title is, and here's the code, and then here's some general context of how you might accomplish that goal. That way you can you can have these prompts be updated on the fly from your MCP server without rewriting your application code. I don't see it used a lot, but I think that might get more popular in the future. A lot of these are actually kind of new. I should have put a history slide in there. MCP was developed in December of last year, so we are not even 1 year old on this technology. It is actually amazing. I don't think I've ever seen, or anybody's ever seen a standard protocol take off this fast. Anthropic made it, put it out open source, and then it's like just everybody jumped on top of it. So from a personal standpoint, I wrote my first MCP server back in April. So that gives me, 6 months of experience, makes me probably one of the most experienced people running with my 6 months. So they keep adding new things to it. Completions, this would be like the same auto-completion you get in a web browser. You start to type a URL and it fills out the rest. It could be the same thing. So the LLM might know part of it, like it might need to know a particular product name, but maybe the LLM just knows the beginning of it, so it could use that to auto-complete the rest of it. There's some logging stuff for like error reporting. Pagination would be like, you have a lot of results. You're pulling let's go back to order history for customers. They have years of history. You don't want that all to come in a context at once, so the model can grab it, piece at a time, keep reading through the history, and continue on. And then streaming for, like it says, long-running goals. It can send updates on progress. Yeah.
So you mentioned you've written a server. So the MCP is just gives you how to connect stuff. But somebody's got to build a server for you actually to be able to query specific tools or API or whatever it is to kind of access tools, resources. So you could have this server over here accesses your email one way, this server over here accesses your email a different way. Or they can do different things because of different tools. Whoever built the server is kind of defining how the interaction is.
Yes. Yeah, you do have to have a server. So this is a way for the language model to talk to that server. So in my case, so I'll go into our app and what I built it for. So we have an art generation app. So people are having, prompting is an important part of art generation. It's become less important, but at the time is extremely important. So to help people write prompts, I put a chat feature in the app. They could then ask the LLM, like, this is what I'm trying to make an image of, like, how would I do this? The app would send it, like what model they were using. This is like art generation models. And then the MCP part would be the language model could then contact we have a database that we put our wiki in that has all the kind of like tutorials on how to do stuff. So the language model grabs that, pulls it back in. So now it's like, okay, I know they're using this model, and that model likes, that's a anime model, so it likes all these weird Japanese keywords and stuff. So I'll be able to translate that back to them. Then the part that I thought was interesting that I did was I wanted a kind of a dual back and forth. So the MCP, so when you chat in the app, you ask it to make a change. Instead of just making a change, it actually brings up UI in the app. So the user can interact. So for example, we have a bunch of styles, like hundreds of styles, and you can scroll through them. So you say, I want anime style, and the LLM contacts our MCP server. The MCP server then writes to their database, which makes an entry and then appears in their chat window. And then it shows them their style selector, and it has the style that they asked for selected. But then they can also change their mind and update it like live. It's kind of like the Canvas feature in ChatGPT, that kind of thing. Can I answer your question?
So basically, you can just build unique tools that nobody else has. That's what kind of. That's
Well,
what kind of.
there's
people
also
look over
two
your-
sides of this. There's you can build your own MCP, so that's a side. But there's also, and we're going to get to that at the end though, there's a lot of MCP servers already out there that you can tap into. So it's not all about, you know, I need to build my own, but you know, so if like doing it both ways. So if you're a company and you want to give the language model ability to schedule appointments or look at your calendar, you would connect to the Google MCP server for that. But you might also want your own private MCP server that connects to your customer data. So if you had a customer call in and they're like, I need to talk to a rep, when is the rep available? Well, it can grab the customer data with your private MCP server, look up who their representative is, and then contact Google's MCP server and look at that representative's calendar, pull in that calendar information, and then schedule the appointment using those the context from both those sources. So both places.
How's the latency?
The latency is, well, it's just whatever latency is on the servers. I mean, ours is a couple hundred milliseconds, fast. You know, there's a little delay, but real time for all intents and purposes. Right. Okay, so this is just a pause, so we're just clear. I went over a bunch of the uses, but MCP really just equals tools. Like, just keep that in your mind. It can do other things, but the crux of it is MCP is tools. All right, so a little bit of how it works. So the LLM contacts the MCP server. The MCP server returns a list of tools available. So going back to the calendar example, one tool might be read calendar, one tool might be write calendar. You can have a tool to update an order for a customer. You know, the MCP. So the important part of this is MCP is discoverable. So the LLM does not have to have prior knowledge of what the server was capable of. It can, on the fly, connect to a new MCP server and grab the information from that server, which then gives it whatever abilities the server gives it access to. And you know, that depends on a lot of things, you know, security and MCP does handle things like authentication. It can wait for you to log on to another server like Google and say, yes, I give permission, and then come back to it and then act on your behalf. So the LLM then reading the list, ChatGPT or Claude Code or whatever you're using, would choose the tool and then fill in the input. Now that's the hope. On a practical level, you know, do they always pick the right tools? No. There's a little bit of, actually there's quite a lot of prompt engineering. I brought this up with this group a bunch of times. Like, a lot of people, if you listen to like podcasts or, you know, social media and stuff, they'll say like prompt engineering is dead, the language models are just going to understand everything. I don't believe that's true. I think you really do have to explain to them what your goal is, where to get the information, and you know, how to get it. So it can grab the tools from the MCP server, but sometimes you gotta lead the LLM with your system prompts. And I'm not gonna get too technical on that, but you know, usually when you're setting up a language model, you also have this like background system prompt that users don't see that will say, hey, you know, use X, Y, Z if this situation comes up. Never say this to somebody, you know, that kind of thing. Although those can be jailbroken, but still worth a try. So the LLM itself does not call the MCP server. that's also a point I think a lot of people don't get. The LLM returns text. It always does the same thing. All it can do is take in text and spit out text. It has no ability to get on the internet, to do anything beyond outputting text. But because of the protocol, it returns text in a format that the app will expect and understand. So your app and that you're creating will read that and be like, oh, this is an MCP call. Let me stop what I'm doing here. I'm going to contact this server, pull in this information, and then dump it back into the context. So it's a subtle point, but I think it's important to understand. And then eventually all you're getting is, again, that's why I brought up that in the beginning, you're getting a long block of context. That's all it is in the end. It's actually pretty straightforward.
So I just want to make sure I understand this correctly, because I'm both kind of excited and terrified. I could conceivably have an app that gets some instructions like, book me some plane tickets, and it hits the server and it gets a list of things. And then I could give it like a second prompt that's like, read this list and tell me which one is getting plane tickets. Is that correct?
Yes.
And so I guess just flat-footed, that seems crazy powerful, and also like it could go horribly wrong. So like,
Yes.
okay.
So, it doesn't defend you against hallucinations.
Yeah.
You could ask it for a list of plane tickets. It could get the list and just say, well, there's always, if they're going to New York, then there's always a flight to Philadelphia, and it can just hallucinate that flight and add that into your list, and you can do that. But that's kind of what I was explaining, that it's important to know that the LLM itself is not actually making the call to the servers. When you say, book me the flight, your app has to intercept that call. Now, your app, everybody's doing something different, so I don't know what angle you're coming from here. That app may be ChatGPT or Copilot, Office 365 or whatever, doing it on your behalf, or maybe something you custom wrote. But that app grabs the call, so it still has a chance to be like, wait a minute, you can't do that. That just doesn't make any sense. So you have more conventional means to intercept those calls.
Yeah. Well, apropos of the prompt engineering issue, just thinking out loud, if I was going to ask it to pick a call from the list, you would want to say something like, hey, and be real sure. And if you're not real sure, like, don't just pick whatever you find, right?
Yeah, I'm not sure if asking that they're real sure. That hasn't worked for me before, but.
Well, okay, sure. Yeah, but there's like
sometimes they double down. They're like, yeah, I am sure, of course. Yeah. So, and that's a whole different. That's outside of this protocol. That gets into like hallucinations and controlling LLMs and the fact that they're black boxes and whole other talk. Okay. All right, MCP versus RAG. Probably should put definition. RAG is retrieval augmented generation. This is an older version of maybe the same thing MCP does, but it's not like outdated. It's just different. But you might be thinking, well, I've already heard of RAG. Why don't I just do that? So what's RAG? So that would be, I would send a chat to my chatbot, and then my app would intercept that chat, and it might do a search. It would like search some database and just pull it in on the behalf of the chatbot, and it would merge that in with whatever I was asking about. So if I said I'm looking for a new pair of shoes, it might just see the word shoes, look up shoes in the database, and say, okay, we got Nike and Reebok and all these different styles, and then dump that into the context. And then the LLM would just have more background information to talk to the user with. So in our app, we actually do a combination because we know what like model they're using. So when they ask the chatbot for something, we can look up that model, we can grab the wiki page with information about it and dump that into the chat. It's just some kind of background history that kind of focuses the LLM. Yeah?
This is super confusing to me about RAG. Like, do you have to create a vector database with all your inventory of shoes or your customer records? Does it have to be vectorized? Or if not, then like, how do you build that query? Do you tell it, give it 3 different parameters it can search on? It's just really confusing.
Okay, so RAG is more of a traditional search. So you hear RAG, and then you hear, like, you were talking about vector database, and everybody's like, RAG equals vector database. RAG does not equal vector database, right? All the vector database people want you to think that, but there's actually quite a lot of debate on what search systems you should use for your RAG calls. And a lot of people argue that your more traditional searches, and that's like the kind of search like pure just regular text semantic searches like Google would do, are just as fast and just as effective as vector databases. So now, somebody else might argue that point. I'd say it depends on what you're doing, and you probably have to test your use case out and see, maybe vector databases are faster. Since we're going on the side, let's talk about vector databases just for a second. Vector databases are, so when a language model has text, it has to turn those texts into numbers, a list of numbers. So in programming parlance, we call a list of numbers a vector. So you get interesting effects when you turn text into numbers. You get things like, I can say, okay, king is this vector, and if I add, take king and I add female to king, I get a new vector, I get a new list of numbers, and that vector is now queen. Now say I subtract female from that, I get a general neutral, I might get monarch as my answer. So vector databases are kind of cool that you can do these kind of interesting searches. But that may be not what you're looking to do in your own business. So more traditional, just text-based, like look for shoe or foot or whatever, text may work just as well for you. So it just depends.
There's pretty good storytelling about what kind of data you have. And if you had really structured data, you would just be like really making your life awful, bringing all this extra high-tech tools. If you could just say, like, what's the number in box 5 on the claim? 10? Okay, great.
Yeah, exactly. Yeah. A lot of people, a lot of times you don't want free-form searches.
Right.
You want to pull up something very specific. So then the difference is what's MCP do. So RAG is your app kind of pulling in. It's doing the search for it. The LLM has no idea what the search is in that case. Your app does the search on the LLM's behalf, and it feeds that into the context. With MCP, the user asks the question, and the LLM has to say, I think I need more information to ask that. The LLM then determines itself what the query would be based on the user's question, and then does the search. So you're looking at multiple calls back and forth. So in fact, sometimes RAG is better if you've actually dealt with LLMs. The cost can get kind of high. You're charged for all your input tokens, you're charged for all your output tokens. So you don't always want to give the language model the freedom to do its own searches when you just know, hey, I can just grab that, put it in there, and then I can save those 2 calls back and forth that it would have to do, or more, because it may have to do one call to see what its tools are, another call to pull the list of things, and another call to do a query. It can really add up when you're talking about many customers doing many calls. So, but yeah, MCP is bi-directional. So they both have their purposes. You really got to ask yourself what you're doing and decide which to use. All right, so the next thing is MCP versus API. So you have, you already have your APIs that you call with your other internal apps. Why do I need this extra wrapper around it? Why can't they just call the API directly? The short answer is they could. You can just give your LLM access to the API. But the longer answer is APIs are complicated. Most APIs you can call have a lot of fields, a lot of choices. They have constraints over what has to be in each field for the call to be legitimate. They have return responses dealing with too many request errors or failures of that kind. MCP simplifies it for the language model. It gives it a smaller subset of the tools of your API that you can call, and it gives you more control over that process.
But at the end of the day, it's still calling the API, right?
Yes.
So the API becomes a tool for the MCP server to accomplish whatever is being asked for.
Yes. So yes, MCP by itself does nothing. So MCP requires something. It's what sits between the model and the API, but there's always an API on the back end.
Why would it be different than RMI or Node.js or some calling APIs?
What?
Why is this different from that deterministic model? How does this benefit me more?
So I think the biggest benefit is LLMs get confused, they hallucinate. You really, if you want to have a successful experience with your LLM, you need to really narrow down its focus into what it should and shouldn't be doing. And I think that's what the MCP really does for you. It also, as a layer, you can use an API directly, but then you have to put in your program that here's my API, here's how you call it, here's all the fields, here's what all they mean. It gets very, very complicated very quick. Unless you had a dead simple API, you're going to be writing a very long prompt to be able to do that. And it can get out of control quickly, and it just, MCP simplifies that. Really, that's the main thing. It's going to it saves you a lot of effort. Okay. Plug and play. That's also an interesting point. The MCP also handles the discovery, which is something that API doesn't do. Meaning, when the language model talks to the MCP server, it not only tells it what the tool is, it describes the tool, it describes how the tool should be used, it can describe, you can actually put quite a lot of information in that. You can tell it, when the circumstances to use the tool are, you can limit the use, like say maybe your tool call is expensive for some reason. You can be like, only use this if they really ask for it. And it describes like what information they would need to plug into that tool. Like for example, it may say, to call this tool, I need the customer ID. Because you're looking up customer information. So just give me the customer ID, and that's all I need, and then you'll call the order history tool and get that back. With API, you would need to program that all in, and you would also need to do it for every single API out there. There's also, one of the reasons this has become very popular is because if you are only an API service, if you're not consuming your own API, so you're making your API available for someone else to use, you are really simplifying the process. So, if we want to, connect to Gmail, before MCP, everybody who wanted to connect to Gmail would have to write into their tool an Gmail API. Now, all you got to do is say, here's the Gmail MCP server URL, grab it, and it will figure out how to do the rest, because the MCP server will talk to it and tell it how to do the rest.
consider the MCP as just kind of having a collection of like your preferences. Like if you go on that, the flight analogy that you're talking about before, you'd say like, I really would prefer a direct flight. I mean, first of all, I want the lowest cost. I'd prefer a direct flight. And so then it kind of has a conflict here. Well, I found a cheaper flight, but it has like 3 stops.
Yeah.
And so it's kind of like going back and forth, and then you're like, well, is this for vacation? What a date kind of really doesn't matter, or is it like for a wedding where I have to be there at this specific
So
date?
the MCP is going to give raw information. It's not necessarily going to keep the preferences, although this is a very broad subject, so everything I got to say with caveat. So in some case, you might have, like for your example, flight. The language model may go to a memory MCP, which is a very common use. Like, so basically, what a memory MCP is like, to the language model, you'd say, hey, I like direct flights only. And the language model would say, okay, I remember that. It would save that on a server somewhere. And then next time you talk to the language model, it would pull that in. So now the LLM has this little bit of information, only likes direct flights. The MCP would say, okay, I can give you the list of flights, but I need to know where they're going, what the time range is, and is it direct or not, right? And then the language model has to fill in that information. So that makes sense. Like, so it's the language model is making decisions, but it's filling in the background. It's just filling in fields in a form. I mean, you can just imagine it as a web page for language models, maybe. Yeah.
So can you also look at the MCP as a way to share proprietary data without actually seeing it? Because so you've got a server. You can access, okay, we use the whole flight thing. I've got a company, and I sit down, I pull all the flight data from the world, and I make it a simplified database.
Yeah.
Right? And I update it every hour or so. So I could build a server MCP and sit there and go, hey, you get more accurate flight arrangement ideas if you use my tool. I'm going to charge you $5 every time you use it. But I've got this update information that's not going to let the LLM hallucinate, because you're going to, I've got a design such as going to query, it's going to create the SQL query, it's going to pull out information, send the context back in, and then
Yeah.
use it on your app, however. So
Yeah,
you can,
I think I should clarify, because I'm going to say yes, because you know, when you're thinking of this, I think you should think of it in that broad scope of like going back to the server and, you know, looking up the information and maybe handling, you know, charging or limits. You may have an API that you charge per request or something like that. Does the MCP do that? No, not exactly. The API is really going to be doing the work, the heavy lifting. But what the MCP is doing is sitting between that API and the client and
let's make sure the API is filled out correctly.
Yes, it's going to make sure the API is filled correctly. And it can sit there and do, you know, for example, in our app, if they're making a change, it's very important to have their customer ID. Like, so we don't have the language model grab the customer ID because that's too risky. Like, it could just make up a random customer ID or get the ID wrong. So the MCP injects the customer ID into the request. So the language model doesn't have to worry about that. The language model gets the request, the MCP server is called with the customer ID, and then it handles formatting the call to the back end of the API. And then, so, you know, everybody has a responsibility, but the way you put it, like, you can really think about it as an API too. Like, you know, if you want to get real technical, no, it's not. It's a wrapper to an API. Technically, it is an API. I guess it's an API to an API, but it is a wrapper.
What's the difference between middleware and MCP?
Middleware.
Like Zapier or, you know, the thing that connects apps to
Oh,
apps?
not a lot. Like,
MCP
So-
seems kind of like generalized proto-middleware.
yeah, obviously in the functionality, they're kind of doing the same thing. So if you have like a tool like Zapier or N8N or something that's doing some kind of automated agentic process for you, those are more like, but they're more triggering on automation. So that'd be like, I get an email in, call my Zapier instance, and then that would then call a language model with that email. The language model would then read the text of it and say, okay, they're asking about this. Let me call this MCP server. So it gets a little complicated because sometimes they can move around, like they're interchangeable. Like you can choose one or the other, and what the right choice is might depend on the specifics of your situation. Yeah.
So the LLM, you said LLM doesn't have the memory.
Sorry?
Like LLM doesn't have the memory to remember the stuff that you receive. The chat, let's say chat.
Yeah, the LLM
Yeah.
has no memory.
No memory. So
Zero.
my question is, so basically MCP is the one that we just try to fit into our information. Like let's say I try to log into my Google Calendar. So if I give my credential and my Google ID, Google password, the LLM is going to look those MCP record or something. Like my ID, my password, they're doing the agent reports, try to go through my Google Calendar to calendar. So like LLM is reading the MCP or just like is it the process that how it works for the like how the
I'm not
MCP
sure
is
how
controlling the LLM?
technical you want to get with that question, but so I'm going to answer it very technically and then we can lighten it up a bit. So what's the LLM do? I ask it for, I want my hotel availability. What rooms are available in the hotel? So what's the LLM actually do? What it does is it returns back text that just is JSON formatted that's like, grab hotel information, and here is what I want. Here's the dates and the location of that information. That's it. So if you call it directly, like you're playing around with it in a chat app or something, you just get a bunch of, you wouldn't even get the information of the hotel, you would get a block of text that is instructions for how to get information in the hotel. That's a little in the weeds, but then your app grabs that block of text and it says, okay, I know what this is. This is a function call. This is an MCP call. I'm going to call that server with this text, and it's already formatted properly for me, because that's an important part, because you have a slight mistake. I'm going to a comma in the wrong place, crash. Just doesn't work. That's why we can't really rely on the LLM to do it by itself. But so it takes that block of text and it says, okay, I know where to send this. It sends it to the hotel, and it makes a brand new chat request. It sends your previous question. You said, what dates is this hotel available? Well, that actually gets sent back a second time to the language model with the hotel dates embedded in it. So now the language model, all it's doing is like literally, you give somebody a piece of paper with the answer on it, and it reads the answer back to you. And that's all they do. I know it's a weird way to think about it, if you haven't wrapped your head around that. And that's going back to the analogy that you ask them something, you give them that piece of paper, they send you back the answer, and then poof, they're gone. That paper's gone, unless you send it back again. But so.
See, in order to remember the stuff for the LLM, it's just we have to kind of create the MCP. Then we have to kind of give the information of our information. The LLM is going to read it, so that it's going to remember forever.
Yeah, but I don't want to say you have to. I'm going to say MCP gives you a better way to do it, an easier way to take what's actually a very complicated process of reading the message of the LLM, figuring out what it wants to do. Because you can do this without it. You can, when we talked about RAG, this is what people were doing way back in 2024, before this all came about, that they would have to parse that and say, oh, they're looking for a hotel room, and then they would have to go grab the hotel information. And it was just like fragile, complicated, and MCP just takes that process and simplifies it.
So does the LLM then have to know all of the tools available to it on the MCP server, like in that original call, in the context of it? Like, say you had an MCP server with 10 different APIs that can be hit, so like 10 different tools, would it have to know that those 10 are all available to it in the context of the original prompt?
Yes. Yeah. And so what will happen in that process is at the beginning of the conversation, and your app would do this, it would actually contact you probably have a lot of MCP servers. You might have, up to 10. There are kind of limits on tools. It really depends on your use case. They say up to 100. I have no way you can get away with 100. If you got away with 10, you'd be lucky, but maybe you could, get away with that many.
What breaks?
The LLM gets confused. It doesn't understand what tool to use in what case. It starts calling the wrong tool or no tool at all. This is just from my personal experience of, I read this and I see 100 and I try 20 and it's like, no, it doesn't know what's happening. So you just have to keep it in mind when you're designing your system. You gotta keep it a little narrow. That's really the main focus.
Is it correct to say the LLM has to choose and you're just giving it to make choices?
Yes. Yeah, so that gets into the topic, which I think would be another very interesting topic, is context engineering, which is a big thing now. And in my view, context engineering is getting the right information to the LLM at the right time, and not just dumping everything in it. Like you hear these things like Google, I don't even know what their context windows are up to, 1 million tokens, 10 million tokens. They give it these ridiculous needle in the haystack. They feed it just what's the equivalent of several books of information, and they're like, find this little bit of information. But every time I've seen one of those tests, they're ridiculous tests. It's got War and Peace, and in the middle it's got a pizza delivery guy. It doesn't make any sense. And yeah, it picks out that information, but I've never been very impressed with that. So in my mind, context information is about keeping your information simple. Trying to get just what it needs, not letting the LLM do too much work. See, they're good at, they're not magic yet, they don't do everything. You keep them focused and they can get the job done, and they're good at the fuzzy edges of where more conventional means break down. They can make those kind of calls, but and maybe in a year from now, yeah, maybe it just won't matter. Maybe none of this will matter because the LLM can be so smart that they will just do everything, but we'll see if that helps. Going back to your question, the LLM, okay, so your app that is calling the LLM on your behalf, the chat app or whatever they're using, the Office app, will call the MCP server first when it first starts up. And the MCP server will then return a list of tools, descriptions of those tools, and descriptions of what should go in each field of those tools and information about how to use the tool. So that's the information the LLM is going to come back with. I also think on top of that, it's practical to give the language model a separate system prompt that says specifically, please use this tool in this case. Although I've thought about experimenting with putting that into the MCP itself. I haven't got around to that, but I think there's something interesting there to be done with organizing that context.
So the LLM does the encoding and decoding of context, right?
What?
LLM does the encoding and decoding of the context, right?
Does it do the encoding and decoding?
Yeah.
I'm not clear what you mean by that
The
actually.
prompt encoding and decoding, splitting multiple, basically multiple tokens and laying those tokens on of the LLM, right?
Yeah, I mean, I'm not sure if this is what you're asking, but you know, what's an LLM do is turns your prompt into a bunch of vectors, numbers, a list of numbers, and it just does very simple. It's just a slope algorithm. It's everybody learned in algebra. It's ax plus b equals w, and it just does this mathematical formula billions of times. I don't even know what the number is. It might be up to trillion.
Is it like a structured
But-
output you have to give to the MCP somewhere from LLM?
The MCP is taking, it's not taking like the vector output, because the LM is then translating, it always takes those numbers and it translates it back to text again. You know, it's just going from text to numbers, bunch of math, numbers back to text, and then the MCP is getting the JSON responses. You see, it's just a formatting for everybody JSON. Just a way of like it's where you put your brackets and your quotation mark and your commas and stuff like that. It's like, this is a response that my MCP server will understand. Okay, compounding power. This is just kind of an interesting thing I was just thinking about, and I've heard some people bring up, is like, you know, what is like, so LLMs might be reaching a little bit of their limits. You know, you're hearing all these, you know, you got Elon Musk, you got OpenAI, they're building these like massive data centers, they're ingesting just ungodly amounts of information, you know, and they're using it to build new language models. But then you look at like ChatGPT 5 versus ChatGPT 4, is it really that much better? It took a lot more data and effort to get it, and the results don't seem that extreme. So, you know, you kind of maybe argue that we might be reaching a bit of the end of the power of what the raw LLM, the text in, text out system can do. But then now we give it access to tools, and I think we're unlocking like a lot of new potential possibilities that we're not even aware of right now. So, you know, LLMs are notoriously bad at math. They've gotten better, but they're still bad at math. But you can give it now a calculator, just like you would. Just like, I want to give the analogy of us, like we use computers as a tool. The LLM itself can use a computer. It can use the own computer that it's running on. It can look up information on the internet. It can actually write programs and give you the results of the programs. That's a tool that gives it additional capabilities. So, okay, this is a list of examples. I was going over some of the like possible like what you might do with MCP. It's off the charts. I mean, just to speak out the list would take hours, and I wouldn't be done. But you know, there's just a few of them up there. You know, manage tickets, process orders, move robots, which will actually come to the demo I'm going to be doing in a few minutes. So. Okay. Specialized models is also an interesting use case I kind of like. When you get into use of these tools, you will find that they get pretty expensive pretty fast. I'm using, you know, just like the ChatGPT real-time voice API recently. And it's, you know, it's costing $1 an hour or something, which is no big deal if you're just playing around with it, but you start to multiply that by your customers and the amount of use you get, you know, it can get pretty high. They have much less expensive but less intelligent models. So these less expensive models can answer basic questions, and then when they get stuck or need more information, they can actually call the really high-end, you know, Claude Opus or ChatGPT 5 and pay the, I don't know, what they're like 80. Claude Opus I think it was like 200 something per million tokens outputted or something like that. Where a lower end model might cost 40 cents per million tokens outputted. So cost saving alone, I think that's a really interesting use case. Okay. Yeah. So yeah, just the point of this slide is kind of leading into the fact that yeah, this isn't a technology that's up and coming. It's here. It's actively being used. Has anybody like not heard of somebody using MCP or like it's? I mean, you're all here, so I'm sure you've heard the topic a bit. So yeah. So Anthropic. If you're not familiar with them, they're one of the big three. So you get basically OpenAI, which everybody's heard of at this point. You get Anthropic, which they're more known for their coding agents at this point, but they are they're a foundation model, and you get Gemini from Google. Those are really your big ones. And then there's some others, but they've all adopted this as a standard protocol, which is really surprising because, everybody wants to own the protocol because owning the protocol is like owning the gateway between one thing and another, and being the gatekeeper is really where the money's at. So, but Anthropic gave it away, which was, I think, a pretty cool choice, and is allowing these other tools to come to be. So, a few other on there that you look at. There's a couple MCP directories. There's actually a bunch of these, but I just put one up for fun. This is the first one that comes up in a Google search, and they have listed over 6,000 different MCP servers that are available. So it's just, I mean, practically any tool that you use like Slack or Jira or any of these. Anything you can think of now, most of them have MCP, or if they don't have it today, they're going to be getting it. It's just taking off like wildfire. Okay, all right. So demo time. So if anybody don't know me, I am also a member of the St. Louis Robotics Association, and robotics is kind of my hobby. So I'm into AI language models and robots, so I like to combine them anytime I can. So what I have here is just like a proof of concept demo. Okay, so this is a program called Gazebo, and this is a physics simulation. So you're basically looking at a living room area, so this simulates gravity and friction and all that kind of information. So down here on the floor, it's kind of blue. I don't know if you're going to be able to see it real well. Where's my mouse? There we go. Yeah, so we have our little, it's a robot right there. And then so we can control that robot. So I'm using a system called ROS, which is called a robotic operating system, and that's just a universal way to send messages to robots. And we can see what the robot sees in this window. So this is a map of the area. So this is a representation of the robot. The white area is the area that the robot knows about right now. These edges here are what the robot sees with its sensors. So it's actually sending out a laser. This is all, of course, simulated on the laptop, but it's sending out a laser, bouncing off of things and reading the distance. The gray area is unexplored territory that the robot has not gone into, so it does not know what's happening. So I created an MCP server, which translates between the raw system and the language model so that the robot can talk to the system. So, I'm going to do the demo here. It's going to be hard to see both at once. Actually, that is not the right one. VS Code. Okay, so I'm using VS Code just because I'm a developer and it's very easy for me to build something for this. In VS Code, I can add in an MCP server, and I won't get into that part, but if anyone wants to see it after the meeting, I'll show you. All right, so now I can ask you questions. I can say, what topics are available? Hopefully the demo is going to work.
You're brave for you to try?
Yeah. Okay. So, yeah, it is working. So, first of all, it calls the MPC server. It says ran get topics from the MCP server. And this is what the MCP server returns. Let's go back up here. So, the MCP server dumps a bunch of raw information about what the robot's capable of. These are like, use a map, navigate, things like that. And then, so the user would not see that normally. So we're in a development environment, and I can see what's going on, but the language model is just going to dump a bunch of raw topics. And I'm really just doing that to get things warmed up and make sure it works. So now I should be able to give it a command. I can say navigate to. Actually, it probably doesn't matter if I spell it or not. Navigate to, and this is a map system, so I'm just going to give it like coordinates in. These are meters. It's like 2 meters forward, 1 meter to the right. At some point, it should figure out what to do. I think we're getting a little slowness on the internet, maybe. Okay, so it is sending a command to the robot. Oh, it's asking my permission first. New thing, always allow. So it's a little bit of the security side, though that is enforced by VS Code itself. So VS Code intercepted the call and said, hey, do you actually want to let this guy do this? Can you ask him again? This is a situation where better prompt engineering would come in handy. It's actually grabbing all the information about what it can do. I would have been much better off if beforehand I had said, hey, if you want to move somewhere, call this particular topic and send this information. Like, it's getting the raw topics from the MCP server. At this point, it's grabbing all the different possibilities from the MCP server, and it's trying to figure out what it can do. And it's actually doing kind of a bad job. Yeah. Actually, I would rather, this might be a fail. Let me switch to Quad Sonnet and do what I do when ChatGPT 5 fails. ChatGPT 5 is a little wordy. And I'm going to be a little more explicit. and this stuff updates so fast. Before, no, okay, all right. I don't think we're gonna get the demo working. It is really doing like silly stuff. And asking lots of questions. So it is talking back and forth, it's just not doing what I want it to do. Oh, now it's sending a goalpost. Okay. Right? Now I think this is locked up. Now it's moving. Okay. All right, no demo. But, you know, as always, it works perfectly until I get here, and then it has all kinds of problems. So the back and forth communication was working. Even in there, it worked, but you could see that the LLM was grabbing, like, it has no idea, local plan, global plan, odometry. It doesn't have that information normally at its disposal, so it's grabbing that from the MCP server. And the last thing, I just couldn't get it to like make the right choice of which service to call. And that goes back to what I was talking about earlier. You give it too many choices and they get confused, and I think that's what's going on here is when we listed the abilities of the robot, the list is huge. So it was doing weird stuff like accessing the life cycle of, you know, if it started up or shutting down. It's like, no, just send it a goalpost. So, okay, so anyway. Try one more time, but any questions while we're waiting for that? Yeah.
I have one, just so this doesn't come up in, you're talking to one server via MCP here, but my understanding is where this gets really interesting is, you know, you could talk to multiple servers, but then each of those servers, they write their own descriptions, kind of advertise what they can do. So is this kicking off a new sort of like SEO style like competition of like sort of like reverse prompt engineering in a way of like, you know, I can do this for you and I can do this for you, and whoever writes it better kind of gets the ultimately gets the LLM to choose them.
Yeah, so the LLM's not going to have like unlimited choices because you're given it which server it is actually going to. So in this case, for example, you can look at the servers. So these are my MCP servers that VS Code has available. And so, you know, I have like DeepWiki, which is documentation for looking up code documentation. And then, you know, down here I have raw. So they're not, well, wait a minute. I was going to say they're not discovering MCP servers on their own. However, there is a concept that's coming out now is maybe an MCP proxy server.
Right. Well, no, I'm imagining you put in 2 MCP servers, and each of them describe all the tools and all the things they can respond to. Now, do I have to write this in a kind of SEO-like way to get the LLM to choose me over a competing one in a system that, you know, different airlines?
From your point of view, who are you competing with? Are you on the side of the...
I'm on the side of the, I think the foreign servers will be the competing ones.
Okay. So that sounds more of a theoretical, but I can imagine it like that like at some point we might just say, here's the directory, like I showed you the 6,000 server directory, and the LLM could look up, it could actually use an MCP to look up that directory, and then pick based on criteria, like what's the most popular thing that I think will accomplish my goal, add that MCP server into its list of servers. This could be, I mean, there's no technical issue with making it happen, whether it works properly. It could be like my demo, like it has too many choices, and too many choices tends to go badly for language models. So, but yeah, and then you could get into like the whole SEO, like how do I get my LLM to pick my MCP server versus somebody else's MCP server, which is an interesting concept. Yeah, this is the Wild West out here, so I don't even know what's gonna happen. There's so many ideas to explore, and what sticks and what doesn't. You know, your guess is as good as mine.
To that question of durability or whatever, it seems like in your apps you're using MCP a lot.
Yeah.
Is it kind of the final word of this protocol, or is it going to be? Is there a risk that it's replaced by another one? You know, you said Anthropic released this. You know, OpenAI could say, "Oh no, here's MCP 2," and now you have to update your apps to support something else.
That you're asking for a prediction in the future, but
Yeah.
But my prediction is MCP is here to stay. That's not just because I'm giving the presentation. It's because it is so wildly supported already. It's hard to imagine going back. It seems to do everything. I didn't get in. I mean, we could keep talking forever. I could have got into the new agent-to-agent protocols. There's some commerce protocols that are happening. And even when I look at those, I look at agent-to-agent protocols where one agent can call another, and I think, why don't you just use MCP? Like, it already does that, I think the only thing they have, A2A is Google's protocol that they're pushing. They're not pushing it real hard, but it's out there. And yeah, it's just, and since MCP is a light wrapper around everything, it makes it agnostic about what you use it for. Like, you can imagine a lot of use cases for this. So no robot. And that is about it. All right. So yeah, future of it. Shared language for all AI tools. I'm a strong proponent. I know you're asking to predict the future, but I don't see any alternative to this.
Sometimes something's perfect, like SMTP has been around for 50 years.
It's simple, it's to the point, it's every use case I've ever had somebody throw at me, it seems to fit. So the only thing that wasn't the greatest was the long-running task and being able to, but they've added streaming to it. I'm sure if it could handle very long-running tasks, like that would be the question. Could it handle tasks that last days or weeks or months? That we're getting to with these agents is people keep extending the amount of time that agents can run, which is a whole another subject we probably could have gone into here, is MCP and the use of agents. So if you have any questions about that, I can field those. But that's all I got. Oh yeah.
When you said they added streaming, I thought it was socket based on the get-go. How does the code for an MCP server look? If you could just tell us it real quick. Do you have to have a WebSocket connection or?
No. There's actually multiple protocols that will run over. So it will do HTTP requests, so just a straight request, and you get a response. You can request and respond, but you can also make a consistent WebSocket connection. So if you want to get real-time streaming data, you have a long-running operation, and now that a lot of these models are supporting asynchronous calls, which is really interesting. So the model can call a server and say it has to, go out and scrape a bunch of web pages, run along. If you ever use like the deep research or something, it could take 20 minutes. But you might want to have the user like get updates on it. Like, okay, well, what's the last web page you looked at? What information you have so far? They can keep feeding that back over a WebSocket connection. The thing I was talking about that maybe you have trouble with is like WebSocket connections that don't always hold over long periods of time. So if you have an operation that's running for days or weeks, which we're getting to this point where we're going to have to start thinking about what happens, when these models run for, a week or two, processing some information or doing some job. And so then you'd have to come up with a different way. But I think then you'd have a whole different situation. The model would be updating a database or something, and you could go and check back into it at your leisure. It's not like you're going to be sitting there for days waiting for your answer. So,
We need a meeting about rogue agents, because it just sounds really cool.
yeah, is Chaos GPT still an active project?
I haven't heard of it. It sounds fun.
I have a question.
Yeah.
So I'm not as familiar with MCP servers, so how do you connect an MCP server to your LLM, like ChatGPT?
So in ChatGPT, yeah, they have the new, let's see if I can pull up the interface. So the answer is like, it depends on your app. I gotta shut this down. Not only this is like, that physics simulation really puts a toll on my laptop.
And are you guys planning on having an agent meeting or about like going in deeper about that?
Maybe. This is good just since we have some dead air. In January, we have a presentation. A fellow who's a member of the meetup is working on a suite of co-parent games using AI tools to build. So that could be pretty interesting for a couple reasons. In general, really like having members present. We're open Q2 of 2026. And who knows what will be going on in AI by then. Rogue agents might be a hot topic in the next 6 months.
So ChatGPT has sources. What is my presentation? I actually don't use this very much, but I did play around with this particular. I mostly use MCP. I might create exclusive uses looking up documentation. Yeah. Just tell me how to find it. So, but yeah, it says it doesn't have it, but yet, there it is. I connected it.
So
That's
those are
made
MCPs right there that you
But
just
yeah,
connect to.
I went to the plus, and you got sources, add sources, and then you have add, and then calendar. So yeah, as much as I talk about how great it is, every single demo fails. But this is the world we're living in, so you all have to use your imagination and think about what it might be like in next year. It will be pretty impressive then.
All right, before I get lost telling awful jokes about rogue agents, let's all go. Does anybody have any final questions? I'm guessing someone has been totally quiet the whole time and has stupid questions. Look awkwardly at people in the back. There we go. There we go.
So they had the OpenAI Dev Day yesterday, and one of the things that was in there was an embedded website within the chat window. They've got connectors that they worked with behind the scenes with these companies like Zoho and Booking.com. And
I don't know about that. I missed I wanted to watch it. I got real too busy. That would be really up my alley watching that. But you know, if I was making it, I would imagine they would because it's just convenient. Otherwise, you're inventing a new protocol. You could, but that's the whole point. One of the main points of it is like you don't want to invent a new protocol. Every time you come up with a new feature, like using a browser, there's no reason why you can't connect to it using an MCP tool, and you have all these other tools, and it's a universal adapter. So, yeah.
And you heard of Cloudflare just came out with code mode recently, like at the end of September they just announced. Have you heard of that? Or?
Code mode from Cloudflare?
Yeah, it's the way they describe it, it's similar to MCPs in nature, but it will allow LLMs to write code to call TypeScript API generation. So it kind of broadens the tool set.
Yeah, I haven't heard of that
it's
one.
New. It's
yeah, I mean, the last thing I know, Cloudflare is working with trying to become a gateway for monetizing products with LLMs. I haven't heard about the code tool. When you say that and you say like, okay, TypeScript, again, my mind just goes to, well, how is that different from this? Can it already do that? I can tie this into a virtual environment. I could spin up a Docker container and, you know, install my NPM dependencies and run Node.js and all that kind of stuff, you know, directly on it. So, but again, it goes, you know, will a new thing come out and be MCP or? I don't think I don't think that's gonna knock it off its throne. It may have a little niche thing that it takes care of, but yeah, I'm not a big Cloudflare fan. They don't have a lot of
Yeah, I think this was positioned not as a competitor, but as like an adjacent tool that can, you know, expand the capabilities.
I think it's them, in my opinion, it's them wanting to be a gatekeeper on something. Everybody wants to be a gatekeeper, but yeah.
Okay. I was pretty curious. There were some points in your presentation where I kept thinking, wow, this could be like a pretty cool cybersecurity nightmare. And then like, there's like just the imagination goes wild. You do a lot of like SQL injection flavored things maybe. Has much thought been given to this? Has anything gone wrong yet? Have I folded this wrong? Like what?
No, I mean, those are all legit results. I mean, you have to deal with security, and it's an issue. It's you're getting a lot of, I don't know if those are the fault of LLMs. You're getting a lot of things in the news. I think it's mostly because of vibe coding that you're getting like these apps. They vibe code them, and then they don't really understand the app, and then they have wide open security, and everybody in the world can just see their, see their databases. So LLM, it doesn't fix it. I don't know if it makes it worse. You can only argue it makes it worse because it makes it easier. So maybe in that sense, making something easier is making it worse. But no, it's still something you have to deal with.